The commutative properties and associative properties, combining like terms. So, if Susie describes this as 3 plus 4, well, she sees this as 3 plus 4 is the same thing as 4 plus 3. From the other side, Ben would say, okay, this is 4 plus 3. And of course, they're the same. The commutative properties state that a plus b equals b plus a, and a times b equals b times a. In English, what that means is you can switch the order of terms when you're only adding or only multiplying. If she adds more to her picture and says, okay, let's look at this as 3 plus 4 plus 2, he can look at this and say, okay, let's say that this is 3 plus 4 plus 2. That's perfectly fine, just the same. He can group these together before adding the other 3. So the associative properties state that instead of the parentheses being around the second part, you can put them around the first part if it's all addition or all multiplication. Association is when we group things together. So this is grouping. Going back to commutative properties, this is about the order of the terms. So the order of the terms is commutative. The grouping of the terms is associative. So here, what we're doing when we say 2x plus 3x, what this is really stating is that we can use the distributive property to say this is 2 plus 3 times x, and then say that this is 5x. The commutative property allows me to say, well, this is the same thing as 2x plus 3x plus 7. I just switched the order of these terms by the commutative property. And now I can combine the like terms. These both have x's. Please do not try to say that this is 12x. 5 apples plus $7 is not 12 apples. This is not 12 and not 12x. This is our final answer. Like terms have the same variables raised to the same exponents and the same radicals. Typically, when we're simplifying polynomial expressions, we will distribute, identify the like terms, and combine the like terms. So here, there is no distribution to be done. There are no parentheses with something multiplied into the parentheses. So now, we will identify the like terms. They have to have the same variable and same exponent. So, for example, here, these have the same variable and same exponent. So, what other things are like terms? Let's see. There's x's. There's negative 3x and negative 4x. And then there's a bunch of y's. And then 5 doesn't have any like terms this time. So, when we combine these, when we combine the x squared terms, we have negative 2 plus negative 7 is negative 9x squared. When we combine the negative 3x and the negative 4x, that's negative 7x. When we combine the 3 and the 2, that gives us 5 minus 4 is 1. And lastly, we have plus 5. If you wanted to finalize this, you would usually say negative 9x squared minus 7x plus y plus 5, because 1y is the same thing as y. Here, the like terms have the same radical. So those are like terms, and those are like terms. 8x doesn't have any like terms right now. So let's combine the 4 and the 5, become 9 squared to 2. You do not change the radical when you're combining like terms. They are indicating that they're like terms. It doesn't become square root of 4. Same thing here, square root of 3 and square root of 3. This is 18 minus 11 is positive 7. And lastly, we have 8x. Last one, we can distribute. So when we distribute 4, we get 4x squared. 4 times 3 is 12, and 4 times 12 is 48. Negative times x squared is negative x squared. Negative times negative 7x is positive 7x. And negative times negative 1 is positive 1. Now we identify the like terms. So the like terms here are 4 minus 1 is 3x squared. Negative 12 plus 7 is negative 5x. And lastly, 48 plus 1 is 49. Thank you.